So with regards to additive, why additive? Why do we use additive as a solution to our problems within industry? And I think as we move into the fourth industrial revolution, there's a lot of changes that are happening, right? The way that we did things 25 years ago is completely different from the way that we're doing things today, right? But the concept of starting somewhere with we need to make something all the way to mass production, I mean, that's all still there. But the steps that happen and the technologies that we use evolve. And CamLogic's here to support and help you and educate our customers as to specifically where additive fits into this process in today's manufacturing age. So moving forward throughout this presentation, we'll be talking about different FDM 3D printing materials, but as a Markforged 3D printing partner, we'll reference back to Markforged many times throughout this, but again, don't think that this is specifically Markforged materials. We'll be talking through a bunch, but why do we represent Markforged? Why is it CamLogic works with Markforged? They're a wonderful company. Their equipment is outstanding. If anybody says, hey, I'd really like to take a look at the X7 machine, or oh, I wish I could see a Metal X machine, we have tons of Markforged 3D printing equipment in our Oxford, Michigan headquarters. So by all means, anyone's got an open door to walk through here at CamLogic, we'd love to have you. Just let us know. But they have a complete additive portfolio, so plastics, composites, and metals. And yes, we will be talking about FDM 3D printing with metal materials today. The folks at Markforged control all their own materials, so they don't just make the equipment. They produce their own materials. And they also have a proprietary software platform for actually being able to print these parts. So we'll talk a little bit about that as we go on. But again, Markforged is a great company. We're proud to represent them. And any questions about it, feel free to just let us know. So getting into 3D printing and kind of moving into the meat and potatoes, so to speak, of this presentation, why additive? Well, there is a significant growth in the adaptation of 3D printing, and it's been growing year over year over year, and it is not slowing down. Things like security, things like adaptation, things like manufacturing, kind of the big boys in manufacturing, so to speak, really taking additive and saying, well, can I do this with it, or can I do that with it? Well, how do we test this? Well, how do I get this? That's all been evolving as we move into, like I said, this fourth industrial revolution. It's really gaining steam. But the thing that is an extremely important driver for all of that and the growth is material development. And if you leave here today thinking about 3D printing and why materials are so important, if you can say to yourself, all right, I have a very specific application and I have to use a very specific material in order to do it. If you can figure out how to extrude that material onto a 3D printed platform, well, all of a sudden a new door opens up for a new application and you're leveraging 3D printing to do it. So FDM technology, fused deposition modeling technology itself, has been around for a long, long time. And that technology really isn't changing. It's simple, it's straightforward, it's pretty easy to understand. It's really, in a nutshell, like a hot glue gun, right? You have a heated extruder head that extrudes plastic material through it and layers it down onto a build platform in order to create a part. Usually the material that's getting pushed through it, I like to refer to it kind of as like a weed wire whip of material. So it's pretty basic and it's pretty straightforward. And again, there's printers out there that can do this and have been doing it for well over 25 years. So with the growth in additive, if the technology is not changing, what is really driving the growth? What is driving adaptation? It's materials. And again, that's something that I hope everybody takes away from today. Here's just a quick overview of the inside of one of the Mark II printers. And if you just look at the guts, there really isn't anything here that's really overwhelming or daunting or holy cow, I can't believe that's in there. You're looking at two extruder heads, a build plate, and you're pushing plastic out through an extruder tip. They're, again, super reliable machines, easy to use, easy to maintain. But again, it's not the machine that's driving adaptation within the industry. It's the materials that are driving that. The controls that you get with FDM are wonderful. You can build your parts basically almost completely solid or sparse fill with like that honeycomb lattice infill if you wanted to save on materials or lightweight your part. The 3D printing softwares will tell you exactly how much material you're using so you can understand costs. It'll tell you exactly how long your print's going to take so you can understand, hey, if I need this by tomorrow, can I get it by tomorrow? And again, this technology is widely adapted throughout multiple industries across manufacturing. And again, it's not like it's a new technology. It's been around a long, long time. Tolerances that you could hold, Markforged states plus or minus 5/1000ths of an inch, positive and negative, so the tolerances are pretty doggone tight. You can do a lot of post-processing with these materials, so if you wanted to do, say, threaded inserts, just undersize your hole and push some bushings in. If you needed to put metal inserts into your part, same deal, undersize your holes and put your inserts in. If you wanted to sand, paint, prime, again, it's a true plastic that you're dealing with. In many cases. So again, a lot of flexibility, a lot of controls. So again, that's kind of a high level quick overview to FDM 3D printing and what it is. So now let's start actually getting into what materials are out there and what can a user be using. So what can I print in? Rob, I know there's ABS out there. Rob, I've seen PLA out there. There's a diverse array of materials that you can print in. There's plastics, there's composites, and like I mentioned, we're going to be talking about metals. If there's something that you want to take away from this with regards to, well, what can I print? Well, why would I print that? It's important to take into account, well, what do I want my part to do after I print it? That would drive whether or not you're using a polypropylene or you're using a nylon. If I need something that's non-marring, okay, well, I got to get a material that's non-marring. If I need a material that, hey, I got end-of-arm gripper tools and the part that it picks up, it's actually a pretty doggone hot part. So I need to make sure that I understand just how much heat the FDM printing material that I'm printing in can withstand. So again, things to take into account. I don't want to go into each one of these and break down the molecular structure of, a corn-based PLA or what's in an alloy 910 or any of that. But the point is, if you're dealing with reputable companies, you're dealing with reputable material suppliers, all of the material data should be here for any of these materials. Use the data, understand what's in the data so that you can say, hey, no, this makes sense. This is what I need. This is the material that's going to be applicable for what I'm trying to do. Little bit of homework goes a long way.